So in the last lecture, what we have discussed, we have started the fixed point iteration method. Fixed point iteration method में हमने क्या किया था? That if I have any function f of x equal to 0, we can reform this function so that it becomes my x is equal to gx. हम क्या करते थे कि सबसे पहले मैंने एक इनिशियल अप्रोक्सीमेशन ले ली x नॉट, राइट, and then we calculate the iteration. मैं x1 कैसे निकालती थी? I'll substitute the value of x0 in the function g. x2 क्या हो जाता था? That means I substitute the value of x1 in the function g, and continuing this xn plus 1 आपका क्या हो जाता था? That you substitute the value in your xn in your g function जिसको आपने reformulate किया. लास्ट क्लास में हमने ये भी डिस्कस किया था that the same function when we have evaluated x square minus 3 equal to 0, we have considered three functions g1x, g2x and my g3x. I have shown you कि अगर मैं तीनों एग्जांपल्स में x नॉट लेती हूँ, कंसीडर दैट टू बी 2, जो मेरा g1x हो रहा था वो भी डाइवर्ज कर रहा था, ये मेरा ऑसिलेट हो रहा था, एंड दिस वाज ओनली माय कन्वर्जेस टू द रूट, दैट इज योर 1.732. सो हमने क्या किया था? वी डिड अ थ्योरम दैट कि जो अगर gx मैं बना रही हूँ उसके लिए अगर मेरा g डैश x less than equal to 1 आ जाए for all x belonging to your AB, then you have a unique fixed point. This we have discussed in the last lecture. Any doubt till here? So continuing that one theorem that we have done in the bisection method, that the order of convergence of your bisection method is 1. So in this lecture, there is a small proof that the order of convergence of your fixed point iteration method is also 1. So the order of convergence of fixed point method will be 1. So the statement can be, the theorem is, let g be a continuous function. Let g be a continuous function on the interval AB such that your gx is also belonging to the interval AB for all x belonging to your AB. And suppose in addition, g dash exists on the interval AB and there exists a constant k that is your less than 1 such that your g dash x comes out to be less than equal to k and k is your less than 1 for all x belonging to AB, then any number x naught in AB, the sequence defined by xn is equal to g of xn minus 1 for all n greater than equal to 1 converges to the unique fixed point fixed point x in the interval AB. So in the last lecture we have done the theorem कि अगर मेरा कोई g continuous function है closed interval AB पे और gx भी मेरा उसी interval में जा रहा है जहां से मेरे x आ रहे हैं, then we have done कि वहां पे मेरा fixed point जरूर exist करेगा. ठीक है, that we have already done. This part we have done in the last lecture. And one more part we have also done कि अगर मेरा g dash that means derivative exist करता है on the open interval a b और कोई constant exist करता है जिसकी वैल्यू मेरी 1 से लेस है और g dash x अगर मॉडुलस 1 से कम आ जाता है तो we have unique fixed point, right? So in this class we are going to do कि अगर ये सब conditions true हो रही हैं तब जो मेरी सीक्वेंस है जो मैं डिफाइन कर रही हूँ कि एक्स एन मेरा है जी एक्स एन माइनस वन, वो कोई ना कोई हमेशा ही कन्वर्ज करेगा इन दैट ओपन इंटरवल एंड विद द लीनियर ऑर्डर ऑफ कन्वर्जेंस, कन्वर्जेस लीनियरली टू द यूनिक फिक्स्ड पॉइंट. द थ्योरम इज क्लियर. टू पार्ट्स वी हैव ऑलरेडी डन इन द प्रीवियस लेक्चर कि अगर आपका जी कॉन्टिन्यूस फंक्शन है और gx भी उसी क्लोज्ड इंटरवल में बिलोंग कर रहा है देन यू हैव अ फिक्स्ड पॉइंट. ठीक है, व्हाट वी हैव डन कि पिछले लेक्चर में हमने किया था वी हैव डन टू प्रूफ्स. अप टू दिस दे आर डन विद द टू प्रूफ्स. आज के लेक्चर में हम क्या कर रहे हैं कि वो जो सीक्वेंस हम डिफाइन कर रहे हैं, जैसे मैंने ये सीक्वेंस बनाई, अगर मेरी ये दोनों कंडीशन सेटिस्फाई हैं तो वो आपके पक्का फिक्स्ड पॉइंट को कन्वर्ज करेगा ही करेगा. फॉर एग्जांपल हमने लास्ट में किया था कि मेरा g1x जो था मैंने बनाया था x स्क्वायर माइनस 3 के लिए. I have added 1 on both the sides and then I have reformed the function. वो इन्हीं कंडीशन को फॉलो नहीं कर रहा था इसीलिए वो मेथड डाइवर्ज हो रहा था, राइट? एंड द सेम 3/x जो मैंने बनाया था, दिस फंक्शन आई हैव टेकन 1 g1x, g2x मैंने लिया था, वो ये कंडीशंस को फॉलो नहीं कर रहा था इसीलिए ये मेथड दोनों ही मेरे gx नॉट कन्वर्जिंग थे टुवर्ड्स द रूट. जो मैंने लास्ट फंक्शन लिया था gx that I have considered 1/x of something, that was converging because that was following this condition. क्योंकि आपकी वो कंडीशन फॉलो कर रहा था इसीलिए वो आपके फिक्स्ड पॉइंट को कन्वर्ज कर रहा था. सो दैट यू हैव कंसीडर्ड कि जो आपकी सीक्वेंस बनेगी दैट विल बी योर कन्वर्जेंट. The previous theorem implies that you can do the both of these parts, that you have a unique fixed point. I am now considering the next case from here that any x naught number, if you take any x naught number, your method will converge. You can consider xn minus x. X I am considering this is my fixed point and this I am considering this is my sequence which is following. xn minus x I can write as, क्योंकि मैं सीक्वेंस ऐसे बना रही हूँ x नॉट इक्वल टू दैट इज माय इनिशियल अप्रोक्सीमेशन, x1 आई एम कंसीडरिंग g ऑफ x नॉट, x2 आई एम कंसीडरिंग g ऑफ x1 टू सो ऑन. xn मेरा किसके इक्वल होएगा, दैट इज gx ऑफ n minus 1. So I can write xn that is gxn minus 1. I am saying x is my fixed point. If x is my fixed point तो मेरा क्या होएगा, x किसके इक्वल होएगा, gx के. So I can write this x as equal to your gx. So by mean value theorem we have done that the secant joining the line, the slope of that line becomes the slope of the tangent, that means g dash psi is equal to your, if you take 2 points, gxn minus 1 minus gx, that will be divided by xn minus 1 minus x. This is your mean value theorem. I have already explained you in the previous lecture what is your mean value theorem. So following this will be equal to my g dash psi This will be your xn minus 1 minus x. Because this is depending on n, so I am writing here g psi n. G dash psi of n, that will be equal to modulus of xn minus 1 modulus and you have given that g dash x is less than equal to 1. That means this quantity is less than equal to k. 1, that is your k times xn minus 1 minus x. Is it clear up to here? I have considered xn my sequence point, x is my fixed point. Then because this is my sequence point, so this is equal to g of xn minus 1 and x is my fixed point, so this is gx. And by mean value theorem, this value will be equal to g dash psi n xn minus 1x. I am separating the modulus, so this is g dash psi n xn minus xn because it is given to us that your g dash x is less than equal to k. That means the whole quantity will be less than equal to k, that is xn minus x. And obviously here this your psi n is belonging to the same interval जिसमें आप fixed point लेके चलते हो, right? If you apply again this condition on xn minus 1 minus x, same xn minus 1 भी आपकी sequence है, तो इंडक्टिवली ये किसके इक्वल आ जाएगा? k टाइम्स xn माइनस 2 माइनस x के इक्वल नहीं आ जाएगा? yes or no? So applying this inductively, it will be your xn minus xn. This will be, if you are saying this is less than equal to this thing, this means k times less than xn minus 1 minus x. And since this k is already here and this is xn minus 2 minus x, one more k has come, so it will be k square xn minus 2 minus x. You can also remember from this way, the number you are subtracting over here, the same power you are getting for the k. You can remember, number 2 you are subtracting, the same power 2 are getting over here. The same if you will apply, so it will be kq and this will be xn minus 3 minus x. Going to the convergence, last में मेरा क्या आ जाएगा? xn and this is your xn minus n minus your point x. This is your x naught point. Because we are subtracting minus n from here, so the power here is n. So xn minus n is nothing but it will be your x naught quantity. Now, since your k is less than 1, this thing limit n tending to infinity, kn किसको approach करेगा? Because your k is less than 1 and obviously you are taking the modulus g dash x आपका modulus में है, that cannot be the negative element, so obviously your k is following greater than 0. So your limit n tending to infinity, that will be your 0. That means this quantity with sequence you are considering, if you take limit on both the sides, this the whole quantity, because limit k n tending to infinity k raised to the power n, this quantity is 0, so the whole quantity will be 0. And you are saying limit n tending to infinity xn minus xn, that you say because less than equal to 0. This is in the modulus, it cannot have negative sign, so this inequality, this is your equal to 0. जब आप लिमिट क्या देते हो equal to 0, that means your xn is converging to your x. That means the sequence which we have considered, therefore xn is converging to x, ठीक है। तो आप कोई भी इनिशियल अप्रोक्सीमेशन लेके चलो उसी इंटरवल में, अगर आपकी वो कंडीशन फॉलो है कि आपका g डैश x लेस देन 1 रह रहा है और gx बिलोंग कर रहा है, तो आप कहीं से भी आप स्टार्ट करो, डेफिनेटली यू विल कन्वर्ज टू द फिक्स्ड पॉइंट, राइट। दिस इज द वन पार्ट। नेक्स्ट हमने किया था द ऑर्डर ऑफ द कन्वर्जेंस इज लीनियर, सो यू कैन नोटिस फ्रॉम हियर दैट वी हैव रिटन xn minus x is less than equal to k times xn minus 1 minus x, or I can write as can I write this thing, right? So जब हमने किया था ऑर्डर ऑफ कन्वर्जेंस, मैंने इसको क्या बोला था, en plus 1, so this is your en plus 1 less than equal to k times this is your error at nth iteration, और यहाँ पे आपकी en की पावर कितनी आ रही है, 1, and this k जो वहां पे c हमने कंसीडर किया था that is already you have given that is less than 1, that means the fixed point iteration method converges linearly. Is it clear? Yes or no? So we will do some examples for which it will be clear. Before that, you can just write the remarks to start with the examples. Since it is difficult to find an interval. It is difficult to find an interval AB for which gx is also belonging to the same interval AB. On contrary, if modulus of g dash alpha is greater than 1, then the iteration method that is your xn plus 1 is equal to g of xn for all n greater than equal to 1, 0, you can, so will not converge to fixed point. If your g dash of any at any point it is coming out to be or equal to 1, no conclusion can be drawn. So what it says कि जैसे हम gx चूज कर रहे हैं, ऐसा इंटरवल ढूंढना कि जिसमें gx भी बिलोंग कर रहा हो, दैट इज क्वाइट डिफिकल्ट। वो क्या कह रहा है कि अगर आप ऑन कंट्रेरी किसी इंटरवल में आप दिखा देते हो कि उसका डेरिवेटिव एक पॉइंट पे ग्रेटर देन 1 आ रहा है, तो ऑब्वियसली वो मेथड आपका कन्वर्ज नहीं करेगा फिक्स्ड पॉइंट को, राइट। The second remarks for finding the accuracy, you can also do that if your method is converging, then this hold xn minus x that will be less than equal to k raised to the power n upon 1 minus k, and so what it says, n here is the number of iterations. This can be the stopping criteria also, कि जैसे आपको चाहिए, जैसे हमने लास्ट में किया था ना कि कितनी नंबर ऑफ आइट्रेशंस लगेंगी कि मुझे अपना एक्यूरेसी लेवल अचीव करना पड़े, सो यू कैन फाइंड फ्रॉम हियर this n and this n both are same, you can write even small n. तो जैसे आपने कहा कि सपोज मुझे एक्यूरेसी एप्सिलॉन चाहिए, so you can find the minimum number of iterations from here, कि आप कितनी आइट्रेशंस के बाद अपने फिक्स्ड पॉइंट को कन्वर्ज करोगे. So this can be the stopping criteria. From this you can find the number of iterations. We will do the example on based on this. The one and the foremost important remarks: if G is P times differentiable, if G is P times continuous differentiable function, and it follows that your G dash, and if your G dash alpha equal to 0 and your double derivative is also equal to 0 and up to pth derivative, p minus 1th derivative is 0 and your pth derivative is non-zero, then we can expect more order of convergence. Then we can expect more order of convergence. So what it says कि जैसे आप g डिफाइन कर रहे हो, अगर आपका उसका फर्स्ट डेरिवेटिव 0 आ जाता है, सेकंड डेरिवेटिव 0 आ जाता है, थर्ड, सपोज आपका फोर्थ डेरिवेटिव नॉन जीरो आता है, तब आपका ऑर्डर ऑफ कन्वर्जेंस 1 नहीं रहेगा, आपका ऑर्डर ऑफ कन्वर्जेंस 3 हो जाएगा, बिकॉज एट द pth it is non zero. So you can even go for this, that you have xn plus 1 g of xn. Can I write this? I can add subtract alpha from this. So if you apply your Taylor series on this, yeah, the Taylor series f of a plus h आप लगाते थे, f of a plus h times derivative of f dash a plus h square by 2 factorial f double dash a and so on. The same I am applying, xn minus alpha square by 2 factorial double derivative and taking up to the pth derivative. So you will have xn minus alpha p by p factorial, the derivative, pth derivative at alpha. So you can notice here कि अगर आपका अल्फा जो है फिक्स्ड पॉइंट है, तो g अल्फा की वैल्यू क्या होगी? If your alpha is the fixed point, what will be the value of g alpha? Alpha. So that will be equal to your alpha. First order derivative is 0, second order derivative is 0, so the whole quantity will be 0. So the last quantity will be left only xn minus alpha p factorial. So you can now notice over here, this will be your xn plus 1 minus alpha. This is xn minus p raised to the power alpha p factorial gp alpha, and when you divide this quantity, or right, if you take this thing, ये अब हमारा क्या आ गया? en plus 1, this is my en. यहाँ पे en की पावर कितनी है? p. So that means here the order of convergence is ये उसी के लिए है जहां पे आपका डेरिवेटिव 0 हो रहा होगा. दैट मीन्स आपके मल्टीपल रूट्स यू कैन से कि एग्जिस्ट कर रहे होंगे, राइट? देयर यू कैन हैव मोर order of convergence. So example we are doing that you have f of x equal to x cube minus 7 of x plus 2. Solve f of x is equal to 0 by fixed point iteration method by fixed point iteration method that will converge to the solution. So now you have given f of x is equal to x cube minus 7x plus 2. आपको इसको सॉल्व करना है, इसका मतलब f of x equal to 0 को सॉल्व करना मतलब किसकी वैल्यू निकालनी है, x की. If you want to apply fixed point iteration तो आपको f of x is equal to 0 को क्या करना पड़ेगा, रीफॉर्म करना पड़ेगा कि वो कैसा बन जाए x equal to gx. So I have equation x cube minus 7x plus 2 equal to 0. I can write this as x cube plus 2 is equal to 7x and your x will be 1 by 7 times x cube plus 2, right? अब आपको थ्योरम पता चल गया है कि क्या मैं चेक कर सकती हूँ कि क्या ये मेरा कन्वर्ज करेगा भी या नहीं करेगा ये वाला gx. So you can also check. And the interval, suppose given to you that you have to find it in the interval for x belonging to your 0 to 1. So now this is your x, this is your gx. Gx अब आपका क्या है, 1 by 7 x cube plus 2. So you have done कि अगर मेरा x 0 1 को बिलोंग कर रहा है तो gx भी किसको बिलोंग करना चाहिए, the same interval 0 1. If you will substitute 0 over here तो क्या आंसर आएगा, 2 by 7. And if you will substitute 1 over here you will get 3 by 7. That means that is also in the interval 0 to 1. So your x is belonging to 0 1. Same आपका gx भी किस में जा रहा है, ultimately 0 1 के बीच में ही रह रहा है. One condition you are satisfied. In the interval this is divisible by 1 by 7, x cube plus 7. This is the interval 0 to 1, the value will lie between. I have told you, if you don't, it is difficult to check this. If you check कि अगर आपका g dash x ही greater than 1 आ जाता तब वो आपका मेथड कन्वर्ज नहीं करेगा. So even in this case you can find your g dash x. G dash x will be your 3x square by 7. Since your x is belonging to your interval 0 1, g dash x का मॉडुलस भी आपका किसके छोटा रहेगा, 1 से, for all x is belonging to your interval 0 1. So your g dash x will be less than 1. That means all the condition of the theorem is satisfied. That means the gx जो मैंने यहाँ पे ये कंसीडर करा है ये मेरा किसी भी इनिशियल अप्रोक्सीमेशन के लिए कन्वर्ज करेगा ही करेगा, राइट? सो यू कैन इवन स्टार्ट फ्रॉम एनी अप्रोक्सीमेशन. Suppose I am taking any approximation, let I am taking any approximation x naught in the interval 0 to 1.5. तो x1 हमने कैसे निकाला था कि मैंने g में सब्स्टिट्यूट क्या करना है, x नॉट मतलब 1 by 7 0.5 cube plus 2. So this is giving me answer 0.303571 and x2 if I evaluate मैंने g में सब्स्टिट्यूट क्या करना है, x1. That means 1 by 7 this the value of x1 plus 2. So it is giving me answer 0.28971083 and x3 you will evaluate g of x2 1 by 7 this value cube plus 2 that will be equal to your 0.2891888016. So if you will check the accuracy level this is equal to 10 raised to the power minus 3. That means चाहे बोलो फिक्स्ड पॉइंट, बिकॉज यू हैव रीफॉर्म द फंक्शन f of x equal to 0 in this form. So the root in this case, the root of f of x is 0.289. That is correct up to your 3 decimal places. Clear? Yes or no? Fine. So you have to just substitute. Next example that you have to solve, e raised to the power x is equal to 4x square in the interval 4 to 5 by fixed point method. By fixed point iteration method. So now this is your function f of x, that is your e raised to the power x minus 4x square equal to 0, right? Now we have to solve this function by fixed point. अगर मुझे fixed point लगाना है तो मुझे क्या चेंज करना पड़ेगा इस फंक्शन को? I have to change this form in the कि वो x equal to gx आ जाए. I can also do like this, that this is my e raised to the power x is equal to 4x square. This is x square, that is your e raised to the power x by 4. If I take the positive square root, क्योंकि मुझे root किस में चाहिए? 4 to 5 में. I am not considering the negative sign. Root of 4, that will be your 2. This is your g1x. The same you can do if you take the log on the both sides, and then becomes, this will be x log e, and that will be your log 4x square. And when you will solve this, you will get x is equal to, that is your log e, that will be your 1, right? So now you have this function x is equal to one function g1x, one function is your g2x. So how you will check कि आप वो कन्वर्ज कर रहा है या नहीं कर रहा? मैंने आपको क्या बताया था, that you can check the theorem कि आपका कौन सा कन्वर्जेंट है. So when you will check this thing, this is not converging to your fixed point, because you can check in this case your g dash x will be e raised to the power x by 2 divided it's by 2 into 2, 4 हो जाएगा, क्योंकि e raised to the power ax डेरिवेटिव इज aex. So आपका x किस में जा रहा है? 4 to 5 में. If you will substitute this value from for all x belonging to your interval 4 to 5, this value is your greater than 1. That's why this method is, this gx will not converge. Is it clear? If you go for this, this is satisfying all the hypotheses, this will converge. You can start with any approximation x naught, 4.5 low, x1 if you calculate gx naught square, so this is coming out to be your 4.3944. x2, that will be your 4.3469, and so on. This will be 4.3253. You can check the accuracy level जहाँ पे आपको converge करना है. Is it clear? So here forming your g of x plays an important role. अगर आप किसी में चेक कर रहे हो कि डेरिवेटिव उसका बड़ा आ रहा है, then obviously it will not converge. One more example that we will do. So if you have to solve x is equal to tan of x in the interval 4 to 5 by fixed point iteration method. So you have here function f of x is equal to, that means x minus tan x. ठीक है? अगर आप इसको सॉल्व करते हो, दिस इज ऑलरेडी इन द फॉर्म x इज इक्वल टू tan ऑफ x, राइट। यहाँ पे ही आपको ऑलरेडी x इज इक्वल टू tan x है, सो दिस कैन बी योर वन फंक्शन। अगर आपको चेक करना है कि ये कन्वर्ज करेगा कि नहीं, सो दिस विल नॉट कन्वर्ज टू द रूट। Why? Because you can take any approximation, x is not is equal to your 4, and if you calculate g of x, that is coming out to be your 1.158, that is not belonging to your interval 4 to 5. So आपका होना चाहिए था कि gx भी आपका 4 5 में जाए, then it can converge. But in this case, it is not going in 4 to 5. So this method will not converge. On the contrary, you can reform this function like this. I can reciprocate it. 1 by x is equal to tan x. And I can add x on both the sides. And this will be your x minus 1 by x plus 1 by tan x. If you check, this will converge. This is your new function g2x. This satisfies all your hypotheses. You can start with any approximation x not even equal to 4. Even in the 4th or 5th iteration, you will get your answer, right? So you will take x not equal to 4, x1 you will get 4.61369, x2 you will get 4.49, 596, and you can perform the iteration. Just substitute the value in your g function. Is it clear up to here? We will do 1 or 2 examples more in the next lecture. Then we will start new method. That is your second method. Thank you.